Alrighty, welcome back to another episode of Let's Look at the Red Stuff on GitHub. So today I think we have 4 items at least, and then we see how fast we actually go. So we first start with some networking stuff. Yeah, Thomas or Chris, take it away. Is it just me, or? So it's not just me, okay. So, okay, I'm not entirely sure I fully understood what you said, but basically, these are all net new APIs, right? So there's not like any existing types here, right? And then do you have some sample code on? Yeah, here we go. So what is the actual result of the operation? Is it just ambient state, or is there something that I get back and then I stuff it into something that actually does authentication? Like, do I extract the remote identity, or how do I use the result? Yeah, I guess my question is, so if I then initiate something like some networking call of, let's say, HTTP client, how does that HTTP client use the authentication I just performed? I guess is my question. So what you just said is the thing I think I've never seen. So what do you mean by blob or challenge blob from HTTP client? Is it a header, or like where does this information go? So I guess then what is on screen right now, the negotiated blob I get back from this API, that is something that I would stuff in the header, and then that's basically my authentication that goes back to the server. Meaning the gotcha, and then eventually that thing is done, and then the last buffer I got, I guess, is now the thing I keep sending.
blob from the client. and we run it through this, and we're like, no, I need more data. I send it back to you. Here's a challenge blob for you. And the end result out of that is a Windows identity and server handles and state that we preserve for the duration of the connection.
Gotcha.
On a side note, go ahead.
Oh, I was just gonna ask Chris. So, like, I'm looking at Kestrel's like reflected usage of the MT authentication type, and then comparing that to the negotiation authentication type. And it looks like you said it's mostly lined up. I imagine we'll be calling Dispose instead of close context and things like that. But do we need like an is completed flag? Because we're grabbing that using private reflection right now, and we use that for our I negotiate state thing. And that's a question for Chris because you wrote it.
This seems to be using the continue needed flag instead.
Oh, okay.
I think there was a property, we talked about it with Philip Navarra, but I think there was a property which tells you whether, but I think the name was different. Let me take a look.
Right. The abstraction I used just has a bool of is completed on the state object here. The negotiate.
It's the is authenticated. So if is authenticated is true, then the authentication is finished.
Yeah.
He renamed it to match SSL stream.
That's fine.
But
I haven't actually seen the negotiate auth API. If you want to scroll back up to that.
Yeah, which one do you want to see?
It's
negotiate authentication.
So there's the client options.
This guy here?
Let's server. Yeah, here, right here. Okay, client or server options is authenticated. You're saying this is the one that says if we're done.
Correct.
Okay, that's fine.
I think at least that was the intention, if as far as I remember.
Oh yeah, it even says no. It was originally called as completed. And then is the target name what's currently the protocol name on that type?
No, that's the SPN you pass in. So I think you would not see it. It would be something the client says. So it'd be like HTTP / blah blah. It's the SPN you're trying to authenticate to, and it could be. I think it should be nullable. So on a server you don't use it.
Yeah. But doesn't the server want to know what the SPN was? I don't actually need it in my version, but
yeah, I don't remember. And if it's available, we can make it available as a property to basically. So if you authenticate, we should be able to get the identity, right? So I would expect the identity has the information somehow. I would need to look at the implementation.
We use the protocol name for like an is Kerberos check right now. We check against like Kerberos and negotiate and stuff like that.
Yeah, so the protocol could be Kerberos, could be NTLM, or could be negotiate.
If you scroll down, does that get a new? Is that a property that comes out here? Okay, package, right?
Correct.
Yeah, that looks like what we needed. And then the remote identity is what was finally negotiated. And then we have get outgoing blob in bytes or strings. Lovely.
Correct. Yeah, so one is basic cipher encoded and one is just a raw blob. So whatever fits you. We debated whether we need both, and we kind of decided it would be handy. We could choose do only one and let the caller to do basic C4, but since the most use cases would be a plain text protocol, you would need to do it anyway. So we just felt it'd be easier if we offer it as well.
So one question I have is we don't. I mean, the API proposal says high level authentication API, but I guess it's high level, I guess, for people that normally just write buffers by hand. So is this basically an API that we expect kind of high level API like HTTP client and things to use, or do we expect normal .NET customers to call these APIs directly?
No, I would not expect users to call it. So we primarily call by either Kestrel, HTTP client, SQL client, or SMTP. And maybe somebody will do some experiment, but I don't really expect anybody to use it widely. So
Gotcha.
it's just taking the private interface, making it public, so it could be consumed outside of runtime repo.
Gotcha.
Without reflection. So that's not for public use, really.
Yeah. Okay. So that makes sense, because I was about to say it seems like if we had this for loop thingy, we should probably have an API that does it. But like if that is part of some other networking API that does the for loop, then I think that's fine.
You really can't, because the for loop is really implemented by either HTTP client or by the Kestrel, not by this thing. That's kind of an example.
Yeah.
So Kestrel receive HTTP request, it would extract the header and say, hey, try it. Is it good enough? No, it gets back block and needs to create a response message, send it back, and encapsulate in HTTP. And so this piece really can't do the loop. It's sort of more like logic loop, more so than something you could do inside here, because you need to communicate with the peer in each iteration.
Right.
Yeah, this is a state machine for tracking the auth state across multiple requests.
Yeah, this is just an in-memory thing, right? So like this basically just produces payloads that are then sent by some networking component over the wire, but this thing itself doesn't send anything over the wire, right? It just does things in memory.
Correct. Yes.
Yeah.
Exactly.
Yeah. It's buffer in, buffer out.
Yeah, that makes sense. That also answers my other question that I had. It's like, why is nothing asynchronous? But if it's all in memory, then it makes sense.
Yeah.
Yeah, I mean, so I think that all makes sense. My only question is, if it's really meant to be like more like an advanced API, is the network security namespace the right place? Is this already kind of the advanced dumping ground for that, or should we put it in some other more remote namespace?
I don't think it matters. I think there'd be a question for you or Jeremy. I don't think Chris would care, nor the other places where this would be used would care.
Yeah, I don't have strong opinions. I don't know much about systemnet security. Like just looking over it, it seems like it's
already fairly advanced.
Yeah, that's what I was thinking.
If we choose to, we can add some text to hide it in, like Visual Studio or whatever, just hide it. But I don't know if we need to go through that effort.
No, I mean, yeah, it's just like, I guess it's not in systemnet, right, where, the high-level APIs live, I guess. I don't even know where HTTP client is. So, probably in HTTP. But, yeah, that makes sense. I mean, it lives where SSL stream lives. I guess that's already advanced enough for people. So, yeah, I think...
Yeah, and we have Negotiate as well, which is the next closest reincarnation of Kerberos. So,
right.
That would be kind of right in a vein.
Yeah, this makes sense.
I mean, the best that I could think of would be, we call it systemnet security negotiator, systemnet security Kerberos or something, and but then it'd be like, well, why is negotiate stream at that higher level? And it's like, fine. So sysnet security seems good enough. I think most of the people who use it directly are on this call.
And so we have get outgoing blob, which basically always allocates. Do we want an API that fills the span, or do we not care?
So there was a discussion about it. I think David brought it up, and the trick is it's kind of hard to know how big the buffer is. And if you scroll down, there was some proposal, there's some interface where like you can do something like whatever thing, memory owner, and I just felt it's like, so this happens once per connection. So basically, once you authenticate a connection, it's a session-based authentication. So once you do the connection, you can do many, many requests over and over and over with the same identity. So it's basically be like typically probably 2 to 3 buffers, which should be transient. So probably would not end up being held too long and would be disposed quickly. So I would personally feel we don't
Yeah, this is not a hot path.
Yeah, I mean that answers my question, I think. And then Jeremy, remind me, what have we set for init properties? Do we use them? Do we not use them?
We've used them in some places, like some of Tarek's diagnostics. We made some get inits, and I think they work at net standard 2.0 when consumed on .NET framework. Whether or not it understands their init or just sees them as set, I don't remember, but I think we've been using them.
We're not allowed to use required, right? Or are we?
I don't even know what that means.
I think that doesn't exist yet, right? I think
You're adding it in like C#11, right?
Yeah, I think that's a new feature. I mean, I assume none of these APIs go to net standard 2.0, right? They just go inbox for 7, right?
Correct.
Yeah. So in that case, yeah, I mean, if the version of C# that ships with 7 has support for required, I think we could use it. I think it's the question whether the feature will land. I think it was on the chopping block a few times. That would be my only concern. But I mean, in principle, like I think init is fine. I think the problem with init might be, I'm not sure what the .NET Framework semantics are for this thing. So it may behave like a setter, in which case, well, yeah, tough luck. People can set whatever they want, but I think for these options types, I think to me it would make sense to make them init, because why would you change them after the fact? But I also don't think it matters, because presumably you clone the settings, right? Or do you, like, what happens if somebody passes you the options and then they change them later? Is it reflected, or is this just forgotten?
I think it would not, because basically when we create the underlying save handle, we pass some flags through the PAL, and we don't use them again. So we basically say, hey, what we want to set on an option on the initial creation, and then it doesn't matter.
So basically, when the constructor is finished, you already read the options and you called some APIs, so you don't actually hold on to the options logically. You just...
I believe so, yes.
Yeah.
I mean, I would need to verify to be 100% sure, but I believe this is the case.
Yeah. In that case, either model would work. I think to me, it largely doesn't matter. I was just curious.
If you want to, we can keep a separate issue open saying, hey, add those things to it if they land, but...
Yeah, I wouldn't bother. Like, I mean, we already have a ton of APIs that are not in it. I was just more or less for ourselves, like what our opinion on this is. Yeah, I can't really comment on any naming here. Like, the naming seems fairly advanced no matter what, so I think I would defer to the people that work in the space whether these names make sense.
There was a long discussion on the linked issue. I eventually, because it was getting too long, I created this new one, but there was a lot of iterations through it, and seems like nobody really object to the names, so I think they are reasonably close to what they should be.
Right. Works for me. And then Jeremy, do you have opinions on the enum? I think you usually care about the 0 member.
Hang on. Can we scroll up and look at the enum quick?
Sure. Here we go.
Yeah, I mean, the 0 member is a invalid member, which usually makes me happy. So, and this is mostly I think this is mostly a return value, not an input value. So
correct. Yeah.
It would matter a little less.
So do you care about not set versus none or invalid or?
I mean, not set, unknown, any of these seem fine. I assume all of these names and possibly their values come from an RFC.
They might, but I'm not 100% sure. Certainly some of them do come from, I think, the GSS API. Some might come from Windows error codes. And I think Kestrel cares only about some, but we basically, I think, put all the ones we know you can get back, and we have mapping for. And we basically would map them, because obviously on Linux or the Kerberos, you might get different ones than on Windows.
And
Yeah.
it looks like
You're
GSS
not
API
expecting
defines symbols, not values. So like it defines that
Right,
there's an
so we're not
error
expected to
called
handle it.
context expired.
Yeah, that's just the question. Is like it doesn't look like we're supposed to be handling this as an int. Like these don't map. It was just what Jeremy's point was
Right.
to some like internal status code.
Right. The PAL
I mean, they
unifies
might,
the
but
two.
like as to the caller, you're not going to see what that was.
We do one weird thing in ASP.NET where we actually try to bucket these into client errors and server errors, so we know who to blame. So we don't try to deal with the whole list. We try to produce just client error, server error, or we don't know what that was.
Gotcha.
I mean, we can shrink it to only the ones you care about, and then the rest will be just unknown enum. But I think Philip tried to sort of make the complete list of things we know about.
No,
and
that's
again,
fine.
there are like status codes, as Jeremy said, so there's nothing you would pass in. It's something you get back, and you know, it's I guess would be mostly for debugging or sort of knowing why it failed. It might be some useful information in there.
Yeah.
Yeah, so would that be, because it looks like at least several of the top set look like they're GSS codes. So those are probably all
Standardized-ish.
reasonable. Like I don't know where no context would map in. Just, it's a word that happens to be on my screen. And bad QOP. So, which maybe that's QOP not supported down from the errors bucket. But yeah, I mean, if this is all PAL stuff, and especially if the errors aren't guaranteed to be consistent across our PALs, then I would probably encourage trimming it to the ones that come from the spec, because presumably all the platforms are capable of producing those. And then if we think that there are important errors to report back, we can do that. Otherwise, I'd make a generic error. And then if we start from generic error, we can expand it later. Which seems like that would in fact map to GSS failure. I don't know.
Maybe. So GSS typically has two error codes. There's a minor error and major error and minor error. So we could do and somehow preserve the native code for debugging, or we can also just shove it to trace logs. I can work with Philip to basically go and see if he can trim the list to something smaller. And as you said, if he prefer to take only the ones which are defined in a spec and then have basically a generic error for the rest, I think we can do that as well.
Yeah, I mean, the only, the things to report back would be anything that's being handled. If it's just being logged, then it seems like tracing is a better response. And then it's things like cert unknown of, I don't know if any of our enums that talk about certificates call them cert versus certificate. I also don't know where a cert would come in from NTLM. I guess it might from curb. But so it's, I don't know how many of these we should look at the words and see if the words feel .NET-y or if they feel consistent. Because like buffer not enough feels, I don't know, a little too grunty for most of what the rest of .NET enums are named. Like buffer too small seems more, or insufficient buffer if we just wanted to quote a Windows code.
Yeah.
So we can do cleanup and we can do second pass if you want to. I mean, I can work with Philip and we can send updated lists and again, try to trim it so we don't spend a time on stuff which might go away.
Yeah.
If that's okay. And maybe do it over email.
Yep, that works for me. One remaining question I just saw, like negotiate authentication. Let me actually scroll up here so we can look at it. The type is disposable and not sealed. do you actually expect people to derive from it? Because if you do, then you probably want to implement the dispose pattern. If you don't, then just seal the type. Like, why would anybody derive from that?
I don't have the answer. I mean, somebody might do some tracing or whatnot. There was some other discussion, I think, with Steve Stiffus from the Windows authentication, where the network credentials could contain any more complicated tokens, and they don't. But as far as this, I
mean, given
don't
that
see
nothing
any
is given that nothing is
Yeah.
virtual, the best somebody can do is add things on top of it, but they can't really
Yeah.
intercept anything. So at that point, you might as well.
I would say,
seal it.
yeah, I would say seal it. You know, I think that'd be fine for all of use cases we know about.
Yeah, I mean,
And again, this is not really public stuff. It's really meant for us primarily. So
this is some complicated, lower level. We're talking about how we talk over native libraries in our abstraction model. Like extension here feels bad, so I'll make Mr. Tobe happy and also suggest sealing it. So one question, because I'm thinking of the fact that this is a thin library wrapper. This is light up on Linux because we depend on Curb 5, which I don't think we have listed as a standard platform requirement. Do we need a static is supported here?
not necessarily. So on Android, this will be powered by managed implementation. So that's something, Philip, I originally did the prototype and he already got it to runtime. So we can do NTLM without any Kerberos libraries. So that doesn't mean that every single platform has to support it, but we can just throw a platform not support it if we need to.
Right. Well, the question really is, are there enough platforms or configurations that are going to be throwing PNSE that it would be useful to put the static is supported to give the hint that this has no chance of working?
I think in 7 there should be 0 platforms like that.
Okay.
So I would say I would not. I feel it's not needed.
Yeah, if it's just, because in the future we may conceive of a SKU that doesn't have it. Yeah, I would agree with that.
Yeah. And then on all these things like is authenticated, is signed, is encrypted, it feels like there's supposed to be properties indicating what the state machine has gotten up to. So why are they settable?
That's a good question, actually.
Yeah, they probably shouldn't.
What about protection level?
I think it again comes from the GSS API. I would need to double check, but I think it is again what was the outcome, so they should not be settable.
Okay, yeah, because all the ones that are reporting state feel like they should be get only. The ones
Yeah, agreed. I'll
any of
double
them
check
are
with Philip.
tweaking, then settable makes sense.
Yeah, I think they shouldn't be. So I'll double check with him, but I think they should be only getters.
Yeah, if you scroll down, I don't know if there are any that should be settable.
Yeah, I was looking at our reflection implementation. We don't set those properties, what it's worth.
And HTTP client doesn't either. We basically treat the object with some flags, and then we only care about the blobs and the status.
Okay, so everything then on negotiate authentication should be get only.
Yep, and again, I'll double check it to make sure we don't screw up, but I agree with that proposal.
That works.
Yeah. As for the options types being get set versus get init, if the negotiate authentication constructors are copying all their values out and then detaching from the options type, then I would just leave it as get set in case somebody has weird scenarios of, well, I want 99% of the options to be the same, but when I do the next one, I just want to change this one thing. So why stop them from calling set, or why move them over to using reflection to call set, which is, 50-50 on what they would do. But if the options are being held and they're complicated things like the JSON serializer state of it's called options, but really it's holding a bunch of data in it, then a init would make sense. But so we do use a init, but only when we need to, I think. And so it sounded like those should all just be get set.
Yep. So here's what I have in notes.
That seems reasonable.
Okay. Anything else, or is that it?
Just as a oh, sorry, I had a quick question since you're still here, Thomas. This is .NET 7 only, correct? This is not an out-of-band package?
Correct. We don't have any out-of-band packages for security, so the answer is no.
Got it. So we would expect that our partners like SQL, who are taking a dependency on this, or who would want to take a dependency on this, would only be able to take that dependency in their new builds when they're already targeting .NET 7. If they have stuff
Right.
targeting Net Standard, for instance, they would not be able to use this.
Yeah, so the SQL client is still kind of iffy because they try to target like Net Standard and go with whatever runtime. So the immediate use cases would be Kestrel and the Android platform handler. But yes, they will be targeting 7.0.
The current project system makes it easy to multi-target. It's not necessarily easy to write your code once you've done so, but it's easy to multi-target.
Well, it's also easy to make your package 5 times the size it used to be, but yes.
It's easy to do. Like everything else, it's hard to do right.
Yeah, don't say that too loud. Oh damn, we're alive.
So basically the plan is do the implementations we care about and work with SQL client eventually with also PostgreSQL. There are other SQL clients, not just us, who are trying to authenticate, and we'll see how far they go and what their strategy is, whether they target specific things or they might have different ways, or at least there'll be a transition option for them in some cases.
Yeah. I mean, it completely depends on how complex the code is, right? So if this is very little code, I think we can do what we did with the Azure SDK folks by just giving them effectively the implementation, right? And then they just copy it. If this is code that we expect that, oh man, there's like some complicated RFC that we have to, effectively figure out in service, then it might be better for us to actually ship an out-of-band package, even though it's just 3 types, right? But that, to me, I would say like, yeah, let's wait until we actually have somebody who needs it, and then let's figure out what the implementation is. But I would not start with that being out-of-band.
Agreed. If you fix the Android and if you fix Kestrel in 7, I'll be happy enough.
Right.
Yeah, I mean, my gut here says these are going to be depending on our native PALs, which means we can't give them code sharing because we don't guarantee the PAL contract version to version.
So you mean like SQL can't call all PAL APIs? Is that what you're saying?
Right, like they can't, if they make a p invoke into libsystemnetsecurity.so, we don't guarantee that the function will have the same signature or that it'll even exist in the next version.
Right.
Yep.
Right. And they already do, and we already have a couple problems with them. So that's basically a way how to get public APIs. They don't have to depend on our internals.
Yeah, that's generally a good idea. Yeah, I mean, as a general rule, like whenever there's an internal API, I'd rather have a shitty public API than somebody depend on an internal API, because that is way more fragile and harder for us to not break than dealing with
Yep.
some advanced API with a questionable name and some weird namespace. That seems a little better.
So anyway, this is one of them. So hopefully it's been in the service for a while. We know what to expect, and
Yep.
And then the only question left is negotiate the right word on all of these? I know that there's NTLM, negotiate, Kerberos, GSS, all these words. To me, they're usually all in the same place. So if negotiate's the right word, it's the right word. I just want to ask the question.
it's the most generic one. So through negotiate, you can negotiate a Kerberos or NTLM or some other mechanism, and we support only those two. So it's sort of the high level of wrapper for those mechanisms.
All right, sounds good.
We call it like add negotiate in ASP.NET too, like for the higher level APIs.
Yep. If that seems reasonable. All right, then I think that we're done with this one. All right, so the next one is just in order, or does anybody have ordering preferences? No? Then
I think what I'd sent out was the dispose pattern next, but
this one
if
here?
no one cares, then who cares?
This is the one, right? Yep, that works.
Yeah. Just because it was the other day when I looked, this and the networking were the only two reds.
Yeah. So, is Shy on the call? If not, I can talk to it probably. Doesn't seem like it. So basically what ended up happening is we exposed this API here on DB batch. I think if we go here, DB batch. It's an API that we recently added in 6.0, right? And so it's an abstract type because that's basically how ADO.NET works, right? There's a bunch of DB types that then the specific providers usually provide their own inheritance for. So then there will be SQL DB, SQL batch, and you know, there's DB data reader and then there's SQL data reader, right? So that's basically one of those types that we expect people to actually subclass. And when we did the type, we did the bad thing where we made dispose virtual, which is not the dispose pattern. And so the question now is, okay, what do we do in cases like that, right? And specifically, Shai was asking, like, do we have an issue already that we need to address? And so basically there's one option that is like just tactical, but we could just say, you know, the providers that inherit from DB batches, they can provide the dispose pattern and then seal dispose basically, which is, you know, the pragmatic fix given that we own most of the providers anyway. The other option would be that we effectively provide the dispose pattern on DB batch, and what we would basically do is you would add a new dispose bool method on it. Now the problem, of course, is when you now subclass, like nothing tells you to override dispose bool and not the dispose one. But it seems like there could be a generic analyzer that we could author that says, well, if the type has both a virtual dispose and a virtual dispose bool, do not override the dispose one, override the one that takes a bool. The benefit of that would be that if we have other cases like this where we messed up, well, we have a fairly straightforward path to fix that. And then anybody who subclassed it and did the bad thing, well, they now get a warning and they can do the better thing moving forward, right? And then the analyzer could also say, like, you know, once you did that, please also seal the dispose one, right? If you really wanted to. But that's basically, I think, the question that Shai has. And I was kind of hard pressed in the team's call to effectively come up with an example where this thing falls apart today, because the dispose pattern is complicated, right? Then I think you need 3 classes, I think, to actually observe the problem with not implementing the dispose pattern, right? But I wasn't quite able to articulate it. So if somebody can succinctly explain where this thing is falling on the face, that would also be highly appreciated.
Well, I mean, for the most part, the dispose pattern only fails once somebody introduces a finalizer, and we recommend public types not having finalizers, but for non-public types, we explicitly don't have opinions.
Right. So then do we have a preference on what they should do? Stefan, what's your question?
Oh, like I know that we recommended the dispose pattern for the longest time, but like I do think the general recommendation is use things like safe handles and stuff and use them in private fields. And it'd is anyone who like implements like inheritable public types that are also disposable. Like, we don't do this in ASP.NET, for example, and I understand runtime has different standards, but it's a lot.
No, I think the general statement holds for us as well, right? I think we had this discussion multiple times. Nobody should ever need a finalizer, right? But the problem is that there is this 0.0001% where you do need one. So, and I think we have talked about the dispose pattern also multiple times. But like I think every time we convince ourselves that we don't need it, we find a case where we do need it. So it's I think we have basically given up on it and said like, let's just follow the pattern. It's easier.
Right. I mean, I know one of our main points ends up being we felt like having if you designed your class prior to 2022, it should look one way, and if you designed it after, it should look another. That we don't like the way that feels, because now things just aren't consistent, which consistency is our watchword here. But I think the proposal of assuming that the virtual dispose has shipped and we can't fix it, it does seem like adding an analyzer that says if you have both, then prefer overriding the other one, or prefer overriding the one that says bool, is good. There, of course, will always be the complexity that you're multi-targeted, and it's like, so fine, I guess pound if net 7 or greater, use this signature for dispose, else use this signature for the dispose that I'm overriding. It feels a little,
that is true,
weird. But again, that I think I just said all the complexity in it, if you're doing multi-targeting, is just what's the signature of the dispose method you're overriding. And then another thing of like, great, now there's maybe a disposing parameter, so let's ask. Or just in the pound if old, you just define const bool disposing equal true, and let the compiler and JIT handle that. So I think the analyzer's good. Changing the type to match the published patterns sounds good, and the fact that you suggested the analyzer to detect when somebody has done the after the fact correction seems like it solves the weirdness of the problem.
And you would prefer that over them just effectively introducing the dispose pattern at the provider level, meaning the first derived type of the abstraction.
I don't have super strong feelings. Like, if we want to say that, this shipped, finalizers are unlikely, the dispose and dispose async are basically, like, neither of them has to deal with potential finalizer state / code that would have gone through dispose false. And that we shrug and call this one an error and move on, like, that's fine-ish too.
Yeah, I think it would be the least amount of work for ADO.NET. I think, I just looked at who gave the thumbs down. I think that was Arthur. And I don't know exactly why he gave the thumbs down, but my gut feel is that he thinks that it's just additional work for very little benefit. So I would say the least amount of work for them would be to just basically add a new dispose bool method and then call it good. And then, whatever the derived types are, they just do whatever they do today, except they override the other one. And then we just have the analyzer on our end, right? Because it wouldn't be specific.
The least amount of work for them to do is nothing.
Well, sure, that's an option as well. I think the question is...
And I comment later in the issue that that's probably the preferred option.
So you would literally
do nothing.
You would literally do nothing. You would just leave the virtual bool, the virtual dispose as is.
Yeah, like I would say we put it in the remarks section. If you're creating a derived type and you want to implement the pattern, here's how you do it. I think it was Arthur or Shay already posted a gist of how to do it, and that's it. Like we just consider it a wart.
See,
Yeah, I mean the. Go ahead.
Yeah, I mean, I don't have any objections to this. Like, it just comes back to what I said earlier. Like, I have a hard time crafting where the current design falls on its face, and that I think would be required to assess whether this proposal to say just do it at the when you derive from it, whether it actually will work or not.
Yeah, I've heard Arthur rant about his dislike for the dispose pattern, and I think I pointed it out, in the chat earlier. Though so many people have expressed that opinion to me that maybe I'm mixing it up. I kind of share that opinion, but it just because it's work when you're implementing these public-based types that are disposable. What was the advantage, though? That's why I have my hand raised. You were suggesting doing the pattern just on the first derived type. Is that not shipped yet? Is that why that would be easier? I was just trying to figure that out.
Who's that question for?
Emo is saying something about, like, instead of doing it on
DB
batch or whatever, which already shipped, sorry.
Yeah, I think the idea wouldn't be to do it in the first derived. You would do it at the first type where you need a finalizer. I think that was the proposal.
Yeah, I mean that would be reasonable for the hierarchy. I'm guessing most of the derived types, I'm guessing, are sealed themselves, which means they don't care.
Especially if you have a finalizer, generally speaking, you should probably be sealed.
Well, I mean the dispose pattern is supposed to fix.
Well, the dispose pattern, I think, is supposed to account for the fact that you might introduce a finalizable type into the hierarchy. But like I do think generally it's a pit of failure to have an unsealed finalizable type. Like that's how do you extend something that is responsible for its own native resource management?
Right, and that's fair. So like our guidance, as I mentioned, when we did 3rd edition, what we left all the guidance for if you have a finalizer what to do, but we added like do not have a finalizer on a public type.
Yeah.
And it's once you're a non-public type, it makes sense. If you're a public type, take whatever reason you had a finalizer and move it to a safe handle. And that's the guidance that we gave. There are existing types. Sometimes people change their base classes. Sometimes people don't follow our rules. ASP.NET. So it's also by rules I mean guidelines. And so the meta point here that I think is maybe worth discussing is, do we think that there might be types in the BCL that didn't do the dispose pattern right, that just snuck through the cracks, and that something like adding an analyzer for if there's both a dispose and a dispose bool, that you should only be overriding dispose bool.
Right.
And similar for dispose async and dispose async core. And I think adding the analyzer is goodness, and it gives us a meta pattern for solving the problem if it comes up on a type that I can't think of a better way to say that we care about.
No, that makes sense. I think the more common anti-pattern I see isn't that both the dispose and the dispose bool method are virtual. It's that someone actually defines a finalizer on the base type, the finalizer which no ops.
Yeah.
So if you had an analyzer, you'd want to detect both cases, and I think that latter case is the one that will trip most people up.
We possibly already have the one for that, and that's I think people were adding the no-op, or I just called dispose false finalizer because for some reason that's what, before Rosalind Anna, FX cop. Like FX cop in .NET 2.0 or the .NET 3.5 era, one of them was like, oh, the correct way to do the dispose pattern is on the thing that defined iDisposable, you should define the finalizer so that no one else ever needs to.
Yes.
And then someone who wrote that rule got yelled at, and then the rule changed to don't define the finalizer unless you need it. But you should still do the dispose pattern right of calling GC suppress finalize, because if the finalizer ever showed up, you want to suppress it.
Right.
Yep.
Yeah. So what I'm hearing is basically we would close this issue as do nothing, and we just would more or less leave the analyzer as a thing in our heads. Next time it comes up, we could do the analyzer, but we wouldn't do it for this one.
We can
could
also
open an issue for it.
Yeah, we can throw the analyzer in the, approved concept. Like we've discussed it, we think the analyzer is worthwhile. We're just not prioritizing resources on it bucket.
Sounds good. Then how about this? Then we close this one. I will offline file the analyzer and then send it an email, and then we just, if it expresses what we discussed here, then we can just mark it as approved. Sounds good to me. I mean, like I just clicked through the SQL data thing, by the way, like most types are sealed, at least in SQL client, except for the reader. So I would assume that it's probably true for the other providers as well. So I don't think people really have a complicated hierarchy. It's usually like a one-stop thing where you have the abstraction and then you have the provider-specific implementations, and that's it. Like nobody else derives usually. And I would think that even those generally do not need finalizers because they usually use safe handles or other things anyways. It's really more about closing the connection.
Yep. And yeah, like that was my guess of the kinds of things they're doing here. They're either returning non-public types, which are essentially implicitly sealed, or that they have probably sealed their types because they say, I'm bit banging against the database here. Why are you trying to touch my type? So in the world of types doing the dispose pattern wrong, this seems the least offensive.
All right, so then that was easy. Which one was the next one here on your list? This one?
Eric Earhart's curiously recursive pattern was the third thing that went red.
Curiously recurring template pattern in generic math interfaces.
So I can talk to it, or Tanner can talk to it as well.
I don't care which of us. I can do it if you'd like, since I think I've got a little bit more context.
That's fine with me.
So generic math interfaces have the curiously recurring template pattern, which is that they have a generic parameter that is constrained to implement the interface with the same generic parameter. So iParsable, for example, is where tself is iParsable of tself. If we were in an ideal world, the language would be shipping self-types, proper self-types at the same time, and these would actually be proper self-types. However, we are not in a perfect world, and that was out of scope for C# 11. And so what we'd like to do is have this analyzer to basically flag users off of doing problematic using these interfaces in problematic scenarios, basically enforcing that the type that implements the interface is the same as the generic type in the interface. So for example, you would not be able to define my struct implements iParsable of int, or more concretely, my struct implements iNumber of int, and things like that. The primary reason for this is, one, users can get into some of the problematic patterns. If you actually declare a type like my struct, then because of the recursive constraint, you actually can't use it in the default pattern. And so you get no access to any of these static abstract members. But also it's going to exist so that we can make a source breaking change around these types and have them implement proper C# self types when the feature comes in the future. which is expected to just be a source breaking change when that feature comes.
What would that look like in terms of code changes?
Potentially something like iparsable this t-self, or where t-self is sum of this, or maybe some new keyword like self, but there'd just be some language syntax for declaring that the generic parameter actually represents the self type, and then that would light up a lot of new functionality in the language for said generic type.
I see. So it's more or less just a shorter way to express what we currently do with a generic constraint.
Potentially. There's not been an official decision on what that syntax would look like yet.
But you said it's source
there's
breaking,
also-
right? So it wouldn't be binary breaking because it's effective. It's similar to like, it doesn't really matter at runtime. Is that
There's no guarantee that the language will implement it in a way that's binary compatible. If they implement it in a binary breaking way, then we will never be able to use self types on these interfaces, and the analyzer will just remain as, don't do this because you're backing yourself into a corner. But they are going to heavily consider the fact that these generic math interfaces are basically prime examples of where self-types would be beneficial, and therefore ideally they don't make a binary breaking change in deciding how that feature is exposed. And in particular, the analyzer will be flagged to specifically R types. It's not going to recognize a general pattern and flag end user types.
Oh, that's just what I was going to ask. So I have to go at 105. I linked in the chat to where we're using this T-self constraint in ASP.NET for I-bind async, which is very similar to the I-parsable stuff. It's a static abstract interface. And we use T-self. We use like the exact same pattern. So I was wondering if you could just like light up on T-self or something. Or but I see that might be a little broad, but like
Yeah.
We could potentially make it a allow list and drive it off of a MS build property or item group maybe, and then individual projects could opt themselves in to the same analyzer behavior. But there was some pushback on the scoping near the bottom of this thread.
I mean, we could just add a custom attribute,
understandable.
right?
I would like that. But
Yeah,
anyway,
I mean,
I have to go.
That seems like an easier solution to the problem.
We're looking only at static interfaces, right? Like we wouldn't do this for interfaces with regular instance methods.
Right. In
Okay.
the this type in an instance method is already effectively a self type of sorts. It's not quite the same because in a dim it refers to a boxed version of the interface if it's an interface over a value type, but they're similar in concepts. It's for static members. There's no way to express this is the containing type per se. There's no implicit this parameter, and so this kind of fills the gap. And for operators in particular, the language requires that that the parameter be recursively constrained, and it requires that the implementer of the interface be the same. Operators require one of the members to be the declaring type, and so this recursive constraint is how they fill that gap there. So this just in general fills that scenario.
Yeah. As far as the self language feature, I don't think the language can make a binary breaking change, because then if you built a NuGet package targeting net 7 where these are considered stable interfaces, and then you loaded it on net 8, it would crash. So I think that they are going to be constrained by how .NET works to not make a binary breaking change.
Well,
but
they wouldn't
sort
make
of
it
breaking
binary.
matters.
It would just be, they would basically introduce a new feature, right? It just means that we can't use that new feature on existing types, right? So but that's a common theme in C#, right?
No, but if somebody defined that they were, I binary integer of their own numeric type, and the binary and the binary integer type has only a binary and not a source breaking change, then them loading their type on a .NET 8 runtime will throw.
No, but that's
Right.
what I was saying.
We'll see a
That's
lot.
saying
It would just
we
mean,
can't make.
yeah, we wouldn't be able to use the new language feature, right? We would just keep doing what we do for .NET 7, which is we just have the generic constraint.
enough. Yeah. Okay.
Yeah, it's ideally the language implements self-types in a way that is source compatible with what we're already declaring. And in that case, then we can make the source breaking change, which will actually now compiler error if you're trying to implement this in an unsupported way.
Yeah.
Whereas if they make a binary break, we won't do anything. We'll just have core interfaces not being able to use a great new feature.
Yeah.
And that's something that they'll heavily consider and take into account to try and make sure it does work.
Cool.
So is it then fair to say, like I'm not entirely sure I fully understood what you said, Tanner, about the statics. Is it fair to say if an interface has statics, then it should be constrained to T-self, or is that completely orthogonal to statics?
It's required for operators, for static abstract operators. It's not required for any other pattern. We could define iParsable to not be recursively constrained if we really wanted to. Although it's potentially problematic to have a scenario where, you have a custom parser that's not the built-in parser. You get into weird edge cases around what that means, how it behaves, how it interacts.
And so the constraint for T-self is not in iParsable, right? It's in the is when you derive from iParsable, you are supposed to put the constraint. And today, nothing tells you that you need to do that. It's just bad things will happen when you don't. And so
it's to access the members of iParsable on a generic type. You have to have where T-self is sub of iParsable. If we had a non-generic iParsable, then it would just be T-self sub of iParsable with no generic postfix, and it would still work.
So I'm not entirely sure I understand. So it's my understanding was that the point of this analyzer would be to give you a warning when you omit this line here. Is that fair?
No, it's the line above it. That line would be the one with the squiggle. Because T-self is recursively constrained, this is an error because you can't actually pass my date of T-self into any method that's constrained with where T-self is iParsable of T-self.
So I guess I'm confused. So without the analyzer, if I just have this part here, does the code compile today?
Yes, but you can't actually use my date as an iParsable. Is the problem.
I see. So, and then
in order to use it in a generic context, you actually have to add +1 to the number of generic parameters, constrain both generic parameters to iParsable of T-self, and it gets a little bit weird in how it has to work and function, and it's just not a recommended pattern for people to use, especially since it doesn't work for operators, and so it won't work for anything that exposes operators directly or indirectly.
So if I would have written public read only struct my date : iParsable my date, that would still work?
Yes, that one works.
I see. So basically that's why it's really the second one that we wouldn't be able to validate without the analyzer, right?
Right. It's when you're defining something like my date is sub of iParsable of date time.
Yes.
That's problematic because you don't have access to any of the iParsable date time functions.
Any of the T-self interfaces that use the T-self in an operator or both in a covariant and contravariant usage already would be a compile error just because you literally can't write it, right?
Yep.
Right.
So this is only when it's only covariant or contravariant and not involving an operator that technically it compiles, but semantically it doesn't work.
So C# will allow you to compile if you explicitly implement all of the operator interfaces. due to a weird quirk in the language that they decided not to limit.
Okay. Feels like you wouldn't necessarily be able to write everything, but
you can't actually access things, and everything gets really weird, and like you just shouldn't do it.
Yeah.
Can someone?
So the
explain-
reason
Sorry, like
I don't like the attribute that Emo proposed, which I think he's about to ask why it's already rejected.
Yep.
The reason I don't like that is because if we think that we're going to be able to get a self keyword that is maybe source breaking but not binary breaking, and we get to apply it to all these, then really the attribute is a point in time problem, and that has to leak in our ref set forever. Making it just be however you do the custom config on an analyzer seems like if the analyzer really only survives, or it really only applies to .NET 7 and by .NET 8 it's fixed, then the analyzer is less of a we're carrying it forever and it has no value thing.
Yeah, I was going to say I'm of a similar mindset, and in fact, I think when this was initially opened, Tanner and Eric had sort of proposed primarily the attribute approach, and I pushed back a little on it because we are considering a self feature in language in the future, and this is really just a stopgap for our own generic math usage. Trying to broaden it by creating an attribute and the heuristics around that attribute effectively creates a competing language feature, in my opinion. I'd rather just wait for that language feature to arrive and just plug the gap with these specific APIs.
that makes sense. I mean, yeah, I think in that case I completely agree.
And in particular for self-type attribute, Jeremy's kind of wrong in that it would stick around in the ref assembly forever, because it's going to be in the ref assembly regardless, because any new language feature is going to have a new attribute, likely called self-type attribute, in compiler services that is emitted under the hood. So we also don't want to burn the name on something that's likely going to be used for the language feature, and that we want to be able to disambiguate and ensure they can use.
Sure,
as
but then that's
appropriate.
part of the language feature as opposed to the thing that we added for this that no longer has value.
Right. And so I think.
Yeah. Sorry, go ahead, Tanner.
I was just going to say, and so I think the like what Stephen was saying, since this is a stopgap, and since we don't want it to necessarily flag user types, I think just hard coding the list of built-in types it impacts is good. And if it sounds like ASP.NET has a consideration where they want the same, in which case having the config allow explicit opt-in via like the MS-build property group would fill the gap of I'm also kind of stopgapping for the language feature, and I understand what I'm doing.
My hope would be that come .NET 8, we can either delete, like literally delete the analyzer, or make it only apply if you're targeting a down level SDK, if we really cared about that scenario.
Yeah, my preference is I feel that the custom config to analyzers comes from editor config or something, but like whatever the normal config model for analyzers is, that we should just use that to allow extending the restricted list of interfaces that it's guarding against. But yeah, basically a explicit don't do this, and then or explicit don't do this wrong for these interfaces, and then allow that list to be extended by config.
Does this then more or less describe what we talked about?
Yeah, and Booyah called out that she thought it maybe should be in the reliability category. I think it's usage or maybe even correctness, because it's around how you're meant to use the API, and because we're going to, unless something goes wrong, we're going to make a source breaking change in the future, so it's incorrect to use it
But
the other way.
There's not really an issue with reliability or correctness, right? It just means that certain things at compile time won't light up, right?
It means that your code will compile, but it won't do what you think it does, and you're not going to actually be able to use it in the way you think it's going to be usable.
Well, but that's what I meant. It just means if you write a generic method, that these operators won't show up in IntelliSense, right?
It means you won't be able to call that generic method with your custom type.
When you say you won't be able to call it,
The compiler will error with it's like CSO 563
Right.
or something like that.
yeah, that to me is not reliability. That just means it's kind of like, when you, let's say you seal a type or something, right, and then somebody can't derive from it. That's not reliability. That just means, you did something and then, or you forgot a virtual keyword, so somebody is not able to override, right? That to me is literally what usage means. You design your APIs to be usable, and if you don't do it, nothing bad happens. It just means that people can't do with your APIs what they wanted. I mean, to me, reliability would mean, code compiles, but at runtimes, bad things will happen, or something that, basically you have a race condition somewhere, or you accidentally free memory and then you use it later or something, right? That wouldn't be this, right? This would just be, if you want to be your APIs to be usable, then please follow this, right?
Yeah.
So in that sense, I would say it's usage.
Right. I was just saying that I was saying that I don't think it's reliability like Booyah had called out, but
Yeah.
that usage is correct, but correctness might also be okay.
There is no correctness.
Okay, there is no correctness one. Then yeah, usage is right.
All right. So given that there was no more pushback, I think we can probably do this. All right, then this one, add APIs for COSE signing. Oh god, it's crypto.
It is crypto. And since David's not here, I guess it's me. Okay, so there's so this is a partner request for a spec that, depending on how you feel like that E works with the English language, is either COSE or COSE. And so this is, we had from ASN.1, we have signed CMS and envelope CMS, and then there was the horrible failed idea of signed XML and encrypted XML. And then JSON has its own notion, and now CBOR exists. So CBOR people have come up with the CBOR version of the same concept, and every one of them tweaks something, which makes every API slightly incompatible with the previous one, and you have to reinvent the concepts. So this is us reinventing the concepts for the 4th generation of I'm sending you a signed payload. So the big spec has 6 major, we've decided to call them message types, which is 2 variants each of 3 different families. And all that we're doing for .NET 7 is the signing family, which is, it calls sign and sign 1. We've decided to call them multi-sign and sign 1. And yeah, so that's the big general thing, and I don't really know the good order to start. So
what's the
questions
type?
would be good.
How would that? I guess this is the core scenario, right?
Yeah, so the core type depends on if you're reading or writing, really. If you're reading, then it's the base class COSE message, so that has all the static decodes living on it. I don't remember. I know there are reasons why we were putting it down there. They may have gone away with recent data, and so maybe we want to lift all the statics onto the types that are actually using, or that they're producing. But Basically, it's, you decode a thing, and if you know you're doing signing, then now you're going to call verify. If you're building one, then it would just be like COSE sign1 message.sign, and then that'll produce a COSE sign1 doing all the work.
What does one mean here? It's just version 1 of the signing algorithm, or?
So in signed CMS, you can have, so you have this document, you have let's call it a contract. You have a contract, you've put the text in, and then, I walk up with my certificate and I say, this looks good to me, and you walk up with yours and you say, this looks good to me, and you have this whole list of all the people who signed it. They're all at the same rank, and it's all good to go. When they did the CBOR version of the spec for COSE, they said, well, most of the time something that gets signed by literally one person, and we can simplify a lot of the encoding and decoding and error states if we just make a special format that only supports one signer. And so sign1 is the special variant of it can only ever be signed by one person.
And so sign1 is a well-known term.
Sign1 is a specific term from this spec. It's in the spec it calls it COSE_SIGN1. Which is distinguished from COSE_SIGN.
Gotcha.
Which is we called sign multi, or multi-sign rather.
And so renaming it to sign single or sign one ONE would not be appreciated then, I guess.
Be a little weird. If we called it single sign, I don't know that people would find it. I think multi-sign they can look at and be like, okay, yep. I see why you called sign multi-sign, given that sign1 exists.
Yeah, I think when we looked at previous crypto algorithms in the past, we said that we wanted to try to keep the name somewhat similar to what was in the spec, because people who are calling these APIs are generally assumed to be people who are reading the spec and then trying to consume it, right? Because they have some kind of task they're trying to fulfill, and there's less of a learning cliff if we just keep the same terminology.
Yeah, I buy that.
Yeah, so that's where sign1 comes from, the spec.
That also answers my second question. So basically there was really only these two derived messages then, because, well...
That's all we're defining for 7. For future versions, depending on how fast somebody actually asks us for them, there will be encrypt and its variant encrypt 0, and then there's potentially also MAC and its variant MAC 0.
Beautiful.
Yeah.
But yeah,
it's a great spec.
I assume though the idea is that because of the way you defined it here, the base type kind of, or whatever the factory is that you designate, would have to know about all the derived types. So it's basically a closed hierarchy. We are the only party here that defines what is extending COSE message. And right now we just only have these two.
Yeah, I think I don't remember if the API proposal shows it, but I think our definition is that it only has an internal constructor, so it's not extensible. It's representing hierarchy, because if for some reason all you really care about is re-encoding a message and reading what it considered its content to be, then it turns out all 6 message types have those same concepts. Rather than there's a couple concepts they all share, but so those are on the base class, and then the signing things are on the sign types, and the
that makes
Mackie
sense.
things would be on the Mac types. And so that's the high level. So I guess we can start with the base class, because that's usually a pretty good place to start. When did you begin with ABC? All right. Yeah, so we have the COSE message, so this is supposed to be a standard 2.0 package. We've already built it and have it for preview. This is, we're circling back and getting the shape approved and making the changes and then removing the, right now it's tagged as experimental, or sorry, the requires preview features. So we're looking to get rid of that after the review. So we've taken, so COSE, C-O-S-E, stands for CBOR, which is itself an acronym, Object Signing and Encryption. So we've decided to just take that and .netify, or take the .NET rules for abbreviations that you keep. So we kept the C capital and lowercase to everything else, even though COSE is a weird word. It's just like HTML. So COSE message is the base class. All of the types have a notion of content. This is a place where we're slightly deviating from the spec because across the 6 types, they don't always call it the same thing. As the comment says here, the signed messages call it payload, but content and payload seem close enough that someone should figure it out. Everything has a notion of protected headers. These are things that the signer or encryptor or whatever can produce that no one else is allowed to change after the fact. So when you read this, it's a read-only map. And then unprotected headers is this weird thing that you can modify after the fact. There are scenarios, they're weird. Like they're viable, but they're weird and we don't need to talk about them here. And then after that, what it defines is the decodes. Again, if we want to say that those should just move to the return types. The reason they were down here is we originally thought we were going to have a general like decode any, but looking into it deeper, we found that we can't always tell what type something was supposed to be by inspecting its content. Some of them are syntactically ambiguous, and so we can't have the decode any, at which point maybe we don't care about having these on the base type. Every message can be re-encoded. The reason you would care to do this is if you modified an unprotected header, then you would need to modify it and then call encode again to get the output. That's spanified, and so that's the last 4 members on the base class.
Yeah, personally, I prefer the statics on the base type, mostly because that gives me a single place to discover. I mean, if you only have 2 things, whether you call COSE sign 1 message.decode versus COSE message.decode sign 1 seems largely the same, but I feel like if you ever extend this, I think it's nicer if you have them all in one place rather than spread to like, whatever the type hierarchy is that you're ending up with. The naming makes sense. The pattern you have makes sense. It's just a fairly straightforward spanifying of our APIs. Seems simple enough.
Your content that returns a read-only memory, does that hold on to the existing payload going in? No, because you're unwrapping something from the payload.
Yeah, so the payloads are decoded into memory owned by the message.
Got it.
So it'll create a new array for it. It's nullable because you can build these messages either with, so again, let's call it a contract. Either you built a thing where you put the contract inside the message, or if you think of how like, PGP signed ISOs live, it's you have the ISO and then next to it you have the PGP signature file. And so you can build a COSE signed message which says, I don't contain the content. So what it actually contains in the payload is a CBOR nil, and then that's telling you have to have figured out, you have to get the content from somewhere else. It didn't come in the file. And so that's what the null return on that means.
And then presumably the header has somewhere a hash for the content that you were supposed to sign or something?
Yeah, so when we get to the sign and multi-sign, we'll see that they have if the content wasn't in the file, that here's the place where you give it to me.
Gotcha.
And then if you give the wrong content, it'll say false. And if you give the right content, then it'll say true.
That makes sense. Any more questions on the COSE message?
Get encoded length is the actual encoded length, right? Not just like a worst case scenario.
For all of the algorithms that currently exist, yes.
Okay, cool.
And then, yeah, so there was one. So get encoded length. We called it get encoded length in ASN Writer, and I think research said we've also used get encoded size somewhere. I don't care.
Oh yeah. That's I think the name's fine. I just wanted to make sure that it wasn't missing like a max or worst case or something prefix.
Right. Well, yeah. So the way they defined ECDSA signatures, they used let's call it the Windows format, which is always a fixed length. If we had defined this and then they came in later and added ECDSA with the variable length encoding, then it would have to be the worst case answer. But right now everything is deterministic in terms of length, if not content. So so right now it's the exact answer.
When you say right now, does it mean we would eventually derive a type from COSE message where we couldn't?
That a combination of so for encrypt, I don't expect it would ever be wrong. For Mac, I don't expect it would ever be wrong. But there have been crypto algorithms invented in the past and then ways to represent their answers where the length of the answer is non-deterministic.
Sweet. So,
and in that case, this would have to just say what the worst case answer would be.
Yeah,
but right now, it doesn't have that problem. And the one place that we've seen this problem in the past, they've chosen the deterministic length instead of the variable length encoding.
Gotcha.
Okay. We can always add, like, if we need to in the future, like get worst case encoded length or something. I don't think this API design precludes that in the future.
It kind of does and it doesn't, right? It depends on if you call it through the base, right? What would we return then? Like just throw or just? Well, I think at that point I agree with Jeremy. You would just give the worst case answer and you don't have the other API.
Right. Because basically the contract would be, it's you call this thing, if you call this followed by the non-try version of encode, that it's going to not throw, but it may return a number smaller than get encoded length did. That would be if they add another weird thing in the future.
Yeah. That's one of the things that makes me a little curious about APIs like this, because if I assume that get encoded length is always just going to be the right answer, and say I rent an array from the array pool and then encode into that array, and for whatever reason throw out the return value from encode because get encoded length gave me an int, like, am I possibly reading uninitialized memory at that point?
Yes, but especially you said you're renting from the array pool, so it was probably bigger than you asked for.
Yeah, but I would slice to whatever get encoded length tells me it was going to write to. Like,
yeah, I mean, this
maybe we just tell people, like, that's a weird answer, don't do it. Yeah.
Yeah, and it would be the proposal from Emo that is, I think, one of the non-read issues of the attribute of do not ignore the return value from this.
Yeah, perfect. Okay.
But basically, that's if you're calling span writing APIs, you have to be smart enough to call span writing APIs.
Okay.
All right, so then COSE sign one message, I guess.
Yeah, so this looks a mess just because of overloading and the platform not supported or unsupported browser attributes. So we have, again, it's not constructible. You only get it from calling decode to read an existing one. If you want to produce a new one, we don't see a scenario where someone wants to create one and then see the object and then call encode. So what we've decided is all of the sign methods just create it logically and then encode it and just give you the answer. And so we have so again, there's this notion of you put the payload inside the content or you put the payload beside the content. So if it's beside it, that's called detached signing. And we decided to name the alternative embedded instead of just sign. That, of course, is, like all things here, a review decision. But so when you have signing detached, basically we just have this spanified notion of you have the content that is the real content we're signing. We have all of the options that you're taking into signing, which is represented by COSE Signer. And then there's this weird extra foofy thing that I don't personally think makes a lot of sense, but the spec writes it in here, which is basically tying some context to it. And so that's called, in the spec, it's called external AAD. AAD stands for additional authenticated data. Depending on which acronym you come from, the A stands for either additional or associated. And in the spec, or what we did here is we went and we chose associated because that's what we called it on AES-GCM. But
yeah,
we can call it external capital A, little d, external additional authenticated data, external data. Like, there's a lot of fungibility. I don't think anybody really cares, and the people who need to do it will figure out what it means.
Yeah.
And it's basically just data that
supposed to
goes
be-
into the signing, right? It's not just context for some continuation callback or something, right? It's input for the algorithm, basically.
It's input to the signature algorithm, but it
Yeah.
is not considered part of the content.
Gotcha. So
Right.
it's just, yeah.
ASP.NET's crypto stack has a very similar concept. You pass something called a purpose string into it, and it affects how the signature is generated, but it's not itself part of the payload. Is that supposed to be a non-nullable byte array parameter?
I think it's supposed to be a nullable byte array parameter that is defaulted to null. But
Nullable.
we had some last minute cleanup here.
Oh, yes, I see it. Okay, yeah.
It's
It helps if I
possible
scroll.
he produced this in a non-nullable context, and so there are no question marks at all. But
Yeah, there are no question marks at all.
so associated data here would be a nullable byte array. This is one of the glorious things in crypto where it actually does not care the difference between null and empty. So we don't have to do wonky things with the spanified version.
Speaking of nullable, is
And-
anything null on COSE message?
So he did show the one there, which is why I'm a little confused.
Oh, I see,
the content property is nullable. Everything
Because
else
it's a
is not.
nullable of T.
Yeah. Yeah,
Yes,
that's why.
because that's a
It's a struct, yeah.
value type.
But then all the other ones, all the reference types here are correct. So if you pass in a payload, it better not be null.
Right, decode sign 1 gives you a message or it throws, and if you give it null, we're gonna ANE, and then if you
Right.
give it empty, then decode's gonna fail.
And then encode always returns a non-nullable as well, right?
Yep.
Yep. Okay, then that makes sense. So one
Right.
question. I
So
had
for
is-
sign,
Sorry.
Okay.
So one question, generally speaking, for the browser support. So what doesn't work in the browser? Because everything here is unsupported except for trying code, which seems odd. I thought that's the worker method.
so the thing that doesn't work in the browser is the browser has no. In the browser right now, we don't have the RSA type or the ECDSA type, so there's literally nothing you can pass to COSE Signer that will ever work. And then this is just the infectious nature of eventually this code touches a thing that talked about those types, so it says this won't work on browser, and then that bubbles all the way up to the top.
I see.
If we wanted to keep the surface clean, we would just make the constructors now for COSE Signer say browser's not supported, and then that would transitively apply to here, but I don't know if the analyzer is going to yell at us in that case or not.
I see. So the COSE signer is the thing that's unsupported, and the reason all these methods are marked is because they take one, pretty much.
Yeah, that type used to be flat parameters into here, but it got pulled out for sanity.
Yeah. I mean, I think there's two options. I mean, there's literally, we could just, if it's already in a separate assembly, we might as well mark the entire assembly as unsupported. That's one way. But if we wanted to say like, oh, there's nothing wrong with declaring types, then I'd be more in favor of saying, you know, literally just mark the entry points, which in your case, I guess, is the constructor for COSE Signer, and then just say, yep, whoever does that, they're not supported, but anybody who just passes data is fine.
Because if you were weird on browser right now, you could call decode, and that would work, because we can read the structure. And you can ask about the content. You just can't create your own because you can't call sign, and you can't call verify because that requires cryptography that we don't have.
Right.
And but you can technically ask if a thing is structurally sound. So.
Yes.
And you could add you can modify the unprotected headers in calling code. So technically all of that would work just fine on the browser. It's super niche. The attributes are painted on the things that just don't work.
Have you given thought, Jeremy, to what it might look like if the key is backed by AKV? Because you can imagine an asymmetric algorithm today that actually is a network call whenever you need to sign something, but now this runs into the tricky topic of like, well, does sign itself have to be async because it is potentially a network call and so on?
So the crypto stack in particular, because Windows already supports network attached HSMs, and that's abstracted from us, cryptography is symmetric. If you're backed by Azure, you have a block and call. Sorry.
If we did at any point ever want to say that the sign method itself could be asynchronous because we recognize that it might be implemented as a network call, does that affect the API surface that you've proposed here?
We'd add more sign asyncs.
Because I could imagine the sign detached async could just be enlightened and say, oh, like not only am I reading from the stream asynchronously, if I see a sign async method, I'm calling that too.
Right. Yeah, that's what I mean. We would add more sign asyncs, but I feel like this is one of those over my dead body type things.
But it sounds like
because it would be so destructive to the universe if we did this.
It would be, yes. But it sounds like if we did want to reinvent the world for whatever reason, that it sounds like maybe we could just add additional stuff here that doesn't foreclose that ability.
Yeah. So in this particular case with sign detached, what we have is synchronous from an array, a span, or a stream. And then we have async from a stream, where the async thing that we're doing obviously is reading from the stream into building the signature context. The associated data is always expected to be a contiguous block of memory, so we don't support reading that from a stream. We could do it in the future if we cared. I don't see it mattering. So the only thing we have as sign detached async is from the stream. We don't have a sign embedded async because our opinionated feeling is if you're using stream to talk about your content, you meant it to be detached, because if you were willing to have it embedded in the contiguous representation of this file, then you can load it yourself. But we feel you're using stream if the file is big, and then you would want it to be detached. And that's just a opinion that we'll run with until proven otherwise.
Makes sense.
Okay, so then, so sign embedded looks like sign detached, except it's doesn't have the stream overloads because, again, as mentioned, it feels like there's only a scenario for stream if you're detached. And then we have the spanny versions. He only did this tries here, but given that, asking ahead of time how big would this thing be is a little bit of a pain. So right now, we could add the sign embedded that writes to a span that is the non-try, but I don't know that that's super friendly. So we'll leave it out until somebody wants it.
Yeah.
And okay, so now verify. So the signs take this object called a COSE signer because they have to specify a whole lot of options. For verify, most or all of the options are now embedded in the content. The only thing you need to provide is the key. And so we take that as asymmetric algorithm, which is the base class of all possible keys that could ever work. Also of some keys that couldn't work. It's up to you to know what to pass in. And so it has the same, it's basically take sign and replace it with verify. So byte array, span, stream, and then the async version reading a stream, and then verify embedded. Similarly, it's sign. That That should also have a byte array version. It looks like that got lost.
Yeah, I was about to ask, like, isn't there an output at some point? Maybe there's the return values are wrong.
Well, verify returns bool.
Oh, because it's just telling you whether it worked. Yes, I guess that's true.
Did this key plus for detached? Did this key context and optional associated data? Do those successfully verify the signature that is embedded in this file?
Well, isn't that then the byte array version?
Yeah, we have it for detached, but the next method group, verify embedded, looks like we only had the span version.
Oh, I see what you're saying now. Okay. Sorry, I have it the wrong way here on my screen.
Yeah. And this is one of those, if we want to say that this is niche or low level enough that we don't need any of these byte array overloads, that's totally fine with me. We were guessing that Emo still thinks that byte array is friendlier and that we should take byte arrays when we can.
Yeah, I mean, we should just be consistent here. Like, if we have it for some, then we should have it for all.
Right.
I generally
but
think
the reason that they're here at all is
no, I still agree with that.
Approachability angle. Plus, again, the what if COBOL.NET wants to do this?
I just copy pasted the signature, so it looks bool verify embedded asymmetric algorithm key nullable byte array associated data equals null. That would be the overload, right? Yeah.
Right. Yeah, because it wouldn't need the detached content. Yeah. So that's just when we added associated data, there wasn't already two method groups. So. Okay, so that's everything for sign one. There's one signer, they can produce it, it produces some bytes. If you want to read one, you call decode, you get the instance, you call verify. If you have 30 keys you want to try, you just keep calling verify until one of them returns true.
And so, sorry, one question. So the verified detached, they're all non-static, is that correct?
All the verifies are instance. So you have to have already called decode to get the message instance, and then verify will use the state that was contained within the message.
Gotcha. And so then, is it then fair to say so you didn't mark the encoding because the encoding is just writing data, and like we don't need to call in crypto APIs anymore?
Correct.
Gotcha.
If you've read one in, the only thing you can do to it before writing it back out is modify something in the unprotected headers object, and then you would just be calling encode so that it serializes that data back out. But you can't have modified any of the crypto properties.
Gotcha. Okay, that makes sense then.
Okay, so multi-sign, it's going to look exactly like sign one up until we get down to the read-only collection of COSE signatures property. And so this is because there's more than one signer in the file, I think 0 is defined to be illegal. There could be one, like somebody has to be the first one. So this is now the multi-sign. So this is the collection that tells you about each of the signatures. If you want to call verify, you'll note that there's no verify on this message type. You have to go to each signature and ask each signature, does this verify? Again, it's a caller problem to figure out which key they want to pass to which signature object. The headers are supposed to help clue you to that, but the spec really just kind of leaves it as a implementation detail, which we've made a caller problem.
So basically what you're saying is signing is the same, verification is the thing that's different. So the overloads literally look the same.
All of the sign detached and sign embedded should look exactly the same. No, that's not true. They start off looking exactly the same, but they all have 2 extra parameters. So if you look after, if you scroll to the right a little bit, they take extra protected and unprotected headers, and that's because in the multi-sign, this notion of protected and unprotected headers, you get one of them at the document level and one of them at the signer level. And so the COSE signer carries the signer's things, and then these optional ones modify the document. So only the original signer can build a protected header at the document level.
That was my other question, because it says multi-sign, but then you only pass in a single signer. That was kind of confusing. I would have
Right.
expected
So
to pass
again,
in-
thinking of how this gets used in the real world, if we go back to the contract analogy, if there's a contract and you received the bytes and then you signed it, you're going to be sending me where you already signed the contract, which means you already needed the bytes to then send me, and then I have to call decode, and then now we get down to this lower method group where we get add signer. So I would call decode, I would call add signer to add me as a signature, and then I would call encode to write that back out.
I see.
Yeah,
So
this would be for things like counter signatures, timestamps, right?
Well, counter signatures would be an unprotected header modifying an existing signature context. This would be a parallel signer.
Okay.
So counters go deep, and this is for wide.
Oh, because it's so if I remove an intermediate signature, I haven't invalidated any outer signatures.
Right. So this is.
Oh man. Okay.
You, me, and Emo can each independently sign it, and then anyone can independently trust any of those, and then any of those can be timestamped or countersigned or what have you. But so this creates new top-level signatures.
So just to echo back what you said, so all these static methods are effectively always the first signer, and then the secondary signer basically starts with decoding and then just add signature and then re-encoding.
Yeah. Like there are very weird cases where we may get something like in our code signing that, the code signing process is going to sign it with a RSA cert and an ECDSA cert, and so now if you're a device that only supports one algorithm or the other, it doesn't matter. We didn't have an opinion. You get to choose either. But we feel that that's rare enough that they can just call sign, decode, add signature themselves. And if we get something in the future, we can take an IEnumerable of COSE signer or whatever.
Yeah, I mean, I buy that.
Right now, there's just not the scenario is super niche for why you would have two signers whose private keys can be represented in the same process.
And why do you have remove signature with an in, just for shits and giggles, or?
So this is copying API from Sign CMS, where we have remove signature that takes an int. The remove signature that takes a COSE signature uses reference equality to figure out the int. So if you knew the int, it's actually better to just pass it.
I guess.
So it's just
this. It turns an O of n operation into it turns a potential O of n squared operation into an O of n operation if you wanted to remove multiple signatures.
Yeah. So
yeah, I would kind of assume this is not hot path stuff, but
yeah, but really,
it's really not.
It's there for consistency with Sign CMS.
Yeah, fair enough.
Yeah. So add signature looks like add signature also needs to have the byte array overload for associated data.
Good point.
The associated data modifications got done, I think, yesterday. So we missed some details.
And add and removing signer is always supported. It doesn't require any crypto stuff. It just adds effectively data.
Add signature actually should, and so this may mean that once we broke it off into COSE signature, that the browser or unsupported browser stopped being as infectious.
Gotcha.
But so add signature does a crypto operation. So
and remove does not.
It would be unsupported browser. Remove does not, because it's just deleting data.
And this also comes back to what I mentioned earlier about if for whatever reason we did want to support asynchronous signing through asymmetric algorithm, then add signature async would be presumably an overload we could add.
Yeah.
But it gets, as Jeremy said, it gets very viral through the stack and we'd have to change a lot of stuff.
Yeah.
But,
we've said no to that notion before.
Yeah. So if we wanted to make this work in browser, does browser support symmetric signing?
Symmetric signing? You mean
sorry, synchronous signing.
So all the browser APIs are async only. Laomi and now Eriki are, getting it wired up. But because you, me, and Barry, none of us think that there's a legitimate scenario for a browser having a RSA key. we barely think there's a scenario for having an AES key.
Yeah.
It's not on our plan. Plus, we'd have to write a managed fallback, which no.
Yeah,
So-
which gets very weird with RSA. Yeah.
So yeah, there's currently no plan for this ever to be supported on browser.
Okay.
If the W3C starts adding, if the W3C adds synchronous API, or we start green threading WASM, or we stop supporting Safari, or Safari starts supporting shared array buffer, then we could talk. But right now, we don't expect the universe to ever align.
Okay. That's fair, as long as we're all accepting of that world.
Yep. WASM is limited. So sad. Okay. So COSE signature. So the type in the middle of the screen right now. This is where, for multi-sign, where all of the verify methods live. Again, it looks like verify embedded just missed the byte array overload for associated data. And yeah, so this is the signers, protected headers, the signer level unprotected headers. So to Levi's timestamping question, for multi-signing, you would say decode and then signatures sub 0. I guess you can't because he said read-only collection instead of list. Oh no, wait, read-only collection is a list because it's named wrong.
Yeah, it has an indenture.
So signature sub 0 dot unprotected headers dot set, and then whatever the magic identifier for an RFC 3161 value would be, and then give it the timestamp. So I said words no one but Levi cared. So this is where all the verifies live because they're on an individual signature level. This also means that we're not making a policy of whether all signatures have to work and that you have to give us a key ring that contains all possible signatures and then we'd match them. It's you have to write the match logic. You have to decide what does it mean if you can only verify one of 3 parallel signers. We recommend success, but it's up to you. And yeah, so that's all the COSE signature is the describing the fact that things happened in parallel constructs, and now you get to deal with it.
Deal with it attribute.
Yeah. So this should be the exact same signatures as the verify from sign 1 because there's no notion of document level versus signer level in the verify algorithm. And then, yeah, I think we have 2 more types to talk about, and hopefully we'll be fast because we've hit end of time. So COSE signer, this represents all of the choices that you have to make when signing. If we ignore the complexity of what happened to RSA in 2012 or so, basically it's you have to pick a key, a hash algorithm, and then you can give us some optional protected headers, which are any header values that are going to be protected by your signature. So they're included in the signature process. And then unprotected headers is this weird, it's sidecar data that can be modified after the fact. So it's the 4-pol. Unfortunately for RSA, it's a 5-pol. So there's a second constructor for RSA that takes the extra piece of data that is a required parameter to the sign method that happened in like 2012. And so unfortunately, the base class taking constructor will throw if it sees an RSA key, and it'll tell you have to call the other constructor. And we feel that this is a little better than just taking a nullable RSA signature padding, because then if you gave an RSA key and you end up in sign, now we have to throw out of sign of, I'm sorry, you gave us an RSA key but didn't tell us what signature padding to use. So this traps the usage in the constructor call.
So how does this help? Like if I don't specify a signature padding, presumably RSA key RSA is derived from asymmetric algorithm, right? So that means it would still end up calling the first overload, right?
So if you had an RSA instance and you just called, key, comma, hash algorithm, COSE header map, etc., then this constructor will throw. It'll say, I'm sorry, the key is RSA, you have to call the other constructor.
Oh,
you're
I see what
missing
saying.
information.
I see what you're saying. So you basically do the type check in the other constructor and say, sorry, you're not supposed to call me. That's why we have the other one.
Right.
Gotcha. Okay.
Right now, there's only one algorithm that will functionally work in the other constructor, but which is ECDSA. Technically, DSA could be added in the future. I don't expect it will because it's a basically dead algorithm, so I don't think they would ever define the algorithm identifier for it. But there are other signature types like EDDSA, which is different than ECDSA, that we don't currently support, but theoretically we could in the future, and those would live here. Or those would go into the first one, because hopefully only RSA ever takes a 5-pool. So these just pack the parameters up to the side methods.
You have both protected headers and unprotected headers as nullable properties. Would it ever make sense just to put Sentinel empty collections there so that they're not nullable? Or is that just not a thing?
So in our implementation, if we will always write a protected header, but if you didn't give us any, we'll manifest one protected header, and if you gave us some, if you wrote the one special protected header, it has to be the right answer or we'll throw. And if you didn't write it, then we'll write it for you. We could certainly make the unprotected, we could make both of these collections do you're allowed to give null as the input, and if you ever try reading them, then we manifest the map for you. So we can take away the question marks on the properties.
Yeah, I just wondered if that would make it easier for people to consume, because then they don't have to have the null check.
Maybe. So for the most part, no one should read one of these. Like,
okay.
It's basically just the 5-pull to pass to sign.
Okay, so it's
you
like
say
an
new
options
signer
object,
of all
then.
your options and then pass it in. It's the same as if we flat packed these 4 or 5 parameters. We just reduced our overload count because we didn't have the RSA signature padding problem.
So at that point, like, why not make it a record? We have ways to verify records upon construction, correct? Or is that just too complex?
I mean, why do you want to record?
If you make it record, then you gain all the withers, and so like.
Yeah.
Okay, fair
who
enough.
cares? This is. It is what it is.
I was just trying to figure out if there was a way for us to simplify our implementation. It sounds like this is already pretty simple.
Yeah.
Okay.
I mean, records usually means less typing for us, but more IL for things we may not need.
Yep. So that's the signer, and then the only weird thing, and I don't know if we even have quorum to really discuss, is the map. So, COSE header map. It is, as a map, it's essentially a dictionary, but it's weird. So the map, it's well defined only if the key is an integer or a string, I think. Yeah. And that's why, so we've made that the COSE header label type, which is basically a union of those two things. And then on values, the thing in the map will be a CBOR encoded value, but we've added the accelerators for if you want to give semantic content, and then there's the custom, there's set value for you just want to share an int or a byte array. And then there's set encoded value, which is you're giving us some CBOR content that we didn't have to understand. And so it sort of looks like a dictionary, but because add is weird, we didn't make it be an anything dictionary. And the in the spec here for COSE maps, they don't call them key and value, which is what we use for dictionary. They call them label and value, and so we have it as enumerable of label and encoded value. And if you want the helper of like give this to me as an int, then you have to like talk to COSE or sorry, talk to CBOR. But it has helpful helpers, like get values at 32.
our guidance falls a bit short, right? So I was just thinking like it would be nice to have a try get encoded value that has an out as a byte array, but then that doesn't help you with the enumeration, right? Enumeration would still can only give you one type, so we would have to basically give you back a read-only memory, I guess. So yeah. That's unfortunate.
And I mean, if you want the byte array, then it would be out the read-only memory and then the next line called to array. We could certainly add an overload that takes out byte array. It makes an out discard annoying if you wanted to call try get encoded value as contains key, but we could do it and we could do the helper for you, but I don't think it'll be common enough to matter.
Yeah, the discard I would probably solve anyways, because it seems weird to say try get encoded value and then discard the value.
Right. There was a piece of feedback where somebody asked, why don't we have contains key? And the answer is because contains key is an anti-pattern in dictionary. But if you really, really only care that it exists, then that's try get encoded value out discard.
I guess. I mean, I've usually done the contains check just to basically throw and say the value already exists. I don't care what the value is. But yeah.
Mm-hmm.
Yeah.
So does that mean set is replacing or adding an entry if the value already exists? Sorry, I dropped for like a minute, so you may have answered that already.
Set is assigning. So create if it doesn't exist and overwrite if it exists.
Okay. So to Emo's point, do we also want potentially an add which would throw if the value already exists? Or just have a Boolean at the end of set value that says throws if exists? I don't know who would be doing this in practice, because if you're generating this map, like you already know what's in it because you're the person who wrote it.
Yeah. I don't think there's a scenario for it yet. If somebody wants it, we would add value, because then you'd have set and add like a dictionary does, and then because the Boolean should I throw is, explicitly disrecommended in the guidelines.
I mean, like, what's the general? I mean, I understand why you have COSE header label, but why wouldn't we not just say this is a dictionary of label, comma, let's say read-only memory of byte? Like, it seems
we could,
and then you could then derive from it and just had the other overloads, right?
So, for the most part, we expect that anyone who would be reading this, what they want to do would be, they look at the map and they call something like get value is int32 or get value is string.
Right.
If they're doing the dictionary, that's going only to be able to give them the encoded value, which is the CBOR representation of the value they're talking about. And so this is where you'll see we have set value that takes a span of byte, which maybe should also take a byte array. And then we have set encoded value, which similar. And it's, if you give set value, then this is like, oh, you wanted to set an attribute here that is, and here's the hash of my data. So you pass in the hash. And then now we're going to take that through the CBOR encoder and we're going to wrap that in what it calls a beaster, which is a byte string. And then, so we'll build the encoded representation of this byte array and then save that in the map. And so it's, as a dictionary, it's weird because you're talking about the thing we think people don't ever want to talk about.
Wait, so are you saying that set value actually has different behavior based on the label that's passed in?
No, set value always takes the value and runs it through the CBOR encoding appropriate to its type. Set encoded value checks that the value is a legal CBOR value and throws if it is not.
When you say according to its type, you mean int, byte array, or string, correct?
Yeah.
Okay.
So it'll become a COSE number, a COSE beaster, or a COSE teaster.
Yeah, because the way that most other frameworks solve this is they would make it a dictionary of label to COSE encoded value, where COSE encoded value itself in its constructor can take an int, a string, a byte array. It could have a raw accelerator on it, and so on. It is adding a little bit of overhead, but it makes this type a whole lot easier.
Maybe, but it's not a COSE encoded value. It's a CBOR encoded value, and this would be literally the only place that the CBOR type shows up in the API surface. Yeah. Like right now, we use system encoding's CBOR, as an implementation detail, but we would start needing to manifest that as a API surface just for the dictionary semantics.
Well, you could cheat, right? You could say we have COSE header key and COSE header value, right? And then you have a map between the two, right? That would not be super weird. And then it's just, documentation that says the value happens to be CBOR encoded, right?
We could. There is the little weirdness of we can give you back the value and we can tell you, oh, this looks like an int, this looks like a B stir, and this looks like a T stir. The map doesn't define you to only having these 3 kinds of payload. It's just they're the 3 common kinds of payload. Sometimes it can be a complex object, which would be when you want to use the encoded value of, this is a CBOR encoded structure. Decode it and figure out what to do.
But isn't that just a factory of whatever that type would be that represents the
yeah,
value?
CBOR encoded value.raw. Like system text JSON has something similar. JSON encoded text.raw or whatever.
I mean, the reason why I like it is because it also solves the byte array problem from earlier, right? You always have a uniform type, and then whether you deal with span memories or byte arrays, it's just, what method do you use on the thing to access it, right? Which seems somewhat nicer. I mean, by that question was basically what do you do under the covers, right? If you have some super, optimized data structure where it makes sense to not use dictionary and just have your own stuff, then sure. But if you just wrap a dictionary, then I think you might be better off literally just exposing it as a dictionary, because then you get all the other APIs for free, right? If you don't have the contains oddity, we just have the regular APIs. Try get value, add value.
Yeah, I mean, for what it's worth, looking at the implementation, COSE header map has one field, which is a dictionary of COSE header label to read-only memory of byte.
Yeah.
So it is internally storing it as a dictionary.
Yeah.
But yeah, so we can certainly make a COSE header value type just to talk about this and let it become a iDictionary, and then
or even just a regular dictionary and just
well, keeping it as a custom type would still there's the is read only, because if you've called decode, the protected headers are always going to say read only.
Okay.
And then B for leaving accelerators so that you don't have to walk through whether it be a struct or a class, to walk through the extra step of, can you just give me the value as a string? It does feel like those accelerators on the map type feel useful.
Do we have a read-only dictionary type in the framework?
We do have a read-only dictionary. We have I think
Awesome.
We don't call it read-only dictionary though. I think we call it read-only keyed collection or some stuff like that, because that's.
No, we actually have read-only dictionary. Yeah, it's an object model. Yeah. Okay, cool.
It has an iDictionary and it just throws from add.
Yep. I think in your world you probably want the freezable pattern though, right? So that your freeze is not public, right?
Right. So so if you've constructed one yourself, it's never read-only. It's only read-only if you've called decode and it's the return value from protected headers.
Yeah. Which seems fine. I mean, I don't think that's super important.
So it's contextually freezable, but it still seems nice to surface that to someone. Technically, iDictionary does have is read-only. So we could just be iDictionary, but that would give up on the accelerators. So I think even if nothing else, it would make sense to be COSE header map extends iDictionary, or COSE header map extends dictionary, or whatever we think the right abstraction is here. So I don't think we want to take the already being over time to design that. So I think this will get a needs work with a comment on the map.
Yeah, and I think the header label is literally just your general pattern of it looks like similar to how we would call like a stringified enum, sort of the name is we had for that, right? Except in your case, it's just int or string.
Yeah, so basically it's strongly typed string, which also has some special ints. In fact, all of the well-defined ones use ints, but the ints are mostly restricted to IANA registries. So strings are custom and ints are defined by a spec.
Can an int and a string label ever be equivalent to one another?
No, because the map lookup would be think of it as the ASN number versus character string. It's the type identifier is part of the key.
Okay.
And there's no order, right?
Since he's backing it with a dictionary, I assume the order's whatever order the dictionary felt like returning it in.
Yeah, I meant more like you only implement IEquatable, not IComparable. So I assume that you can't compare labels in terms of ordering.
Oh, yeah, no.
Yeah.
Yeah, I don't think it would be a breaking change to add that in the future if we needed to.
Yeah.
I mean, it wouldn't. How would you compare the number you went to a string one? Like you crossed the
You
domain.
just say canonically one is less than the other.
Yeah.
we do that all the time in our other types. Like in a lot of our other types say that null always compares less than not null, even though they're different domains, as it were.
Yeah. So here's the notes that I have. Anything that I missed?
Yeah.
Is this its own assembly?
Yes.
Okay.
The assembly is net standard 2.0.
Yeah.
Because
yes,
the first party partners are on framework.
I understand.
and when it ships, it's not part of .NET 7, right? It just only ships as an OOP, presumably.
It is not part of the shared runtime.
Yeah.
Right.
So it's .NET runtime, but not shared runtime.
So if we ever added, it would just be a trivial OOP, like immutable collections, where the OOP replace the inbox version if you ever have to. So yeah, that's nice.
Yeah.
Yeah, I mean, then let me just bounce it back to needs work so you can come up with how you want to do the dictionary. And then, but I think we pretty much have it almost done at this point, right?
Yeah. That seems like a relatively minor nit, to be honest. Like, I think for the most part, everyone was very satisfied with the shape.
Yeah. It's also, I think, the first crypto API where I feel like I might be able to use it if I ever have to.
Well, it's a high level one. It's supposed to be friendly.
Yeah. We're actually really good at making good high level crypto APIs. It's the low level stuff, the primitives, that are a bitch to use.
Yeah, of course.
But okay, so aside from making sure that all the overloads of associated data take both byte array and read-only span, that
I feel like I already did this.
The real work was just the map. So
as we talked about. Same with the nullability. Like, I added the nullability here as a comment because I'm not sure I got them all, but
yep,
I feel like I fixed up half of them at least.
And okay, so yeah, when we come back and have quorum again, I'll make sure that everybody's good with multi-sign, like that we're manifesting the word multi that doesn't come from the spec to help disambiguate it from sign 1. But I think that's really the only make sure we're happy with this before it goes out the door.
How do they call it? They just call it signing?
They call it COSE sign and COSE sign 1. And
yeah. COSE sign
and I think
message,
if we had COSE sign message and COSE sign 1 message, like that little 1 in the middle, I don't think it's enough of a identifier. So I like the multi as an infix.
Yeah, I agree.
I agree with that.
You could also do sign N, but then it's even worse.
Yeah.
That just looks like a typo.
Yeah.
True. Yeah. All right. So I'll consider that enough of a quorum, but I don't think that was any of the community feedback either. So, but we did get the why aren't you a dictionary? And so we'll, since Emo also wants us to be a dictionary, then we'll be a dictionary.
I wonder if that's something we should actually consider for our other types as well. Like, we have a lot of types that are dictionary-like that maybe we should just say this is a pattern we'd prefer for people to use going forward. Like, use a regular dictionary if you can, and then just change t value to something that's domain specific, especially if it's a discriminated union.
I think that's generally preferable. I think the problem that you often have is when your domain specific or specificity is involved with the way you do lookups. Then dictionary is kind of bad because you you basically have to
Oh, yeah,
implement
yeah, yeah.
dictionary yourself entirely from scratch at that point, right? And then the API might be a significant ask on you to implement.
And
Yeah.
this, like, we could certainly, as a decision, we could potentially get rid of the COSE header map and say that we take an read-only dictionary of COSE header key to, or COSE header label to COSE header value in all the places that we currently take COSE header map, but that feels just weird. Basically, the thing that the map would be doing at that point would just have the accelerators for you get to ignore the value type of, like, that we'd probably keep all the set values and get value as is. But that'll be a thing we'll talk about next time.
Yep.
Sounds good. All right, then I think this is it for today, and then I see you guys on Tuesday, I think.
All right. Auf Wiedersehen.